Right, okay. Now let's start. What is the first MCQ, chemistry MCQ that we have? Look at this one. The cause for the pain when stung by red ants in the formic acid, which they applied on the sting. Application of which of the following on the sting is most effective to uh, relieve the pain? So they have given 4 answers: salt water, water, lime water, and vinegar. What is the answer? No, Kavin. Good try, but it's not the answer. What is it? Yeah, Amal, your answer is correct. Students, remember now
answer correct.
this is regarding acid-base reactions.
Answer correct.
This is regarding acid-base reactions. Look at this only.
ஒரு பொடிய பிள்ளைய சொன்னேன் நான் சரியா சொன்னேனா
So this is MCQ number 4, right? Now formic acid means it's an acid. We know that acid means what? Acid means someone who can produce H pluses to the medium, right? So we know that acid. What is the definition for acid? We can consider acid a chemical substance. A chemical substance releases H pluses. Releases H plus in an aqueous medium. In an aqueous medium is considered as an acid, right? If you can remember, acids are 2 types. What are the 2 types? Now, what are the examples for the acids? We can say, first of all, let's write down a few examples for acids. What are the examples? We can say HCl, HNO3, right? H2SO4. Then we can say H2CO3. Then CH3C double bond OH. Okay. HCl means hydrochloric acid. Hydrochloric acid. HNO3 means nitric acid. Remember the names. Nitric acid. H2SO4. What is H2SO4? Name it. What is H2SO4, students? Sulfuric acid, right? H2SO4 means sulfuric acid. Then H2CO3, right? H2CO3 means carbonic acid. Carbonic acid. What is this CH3C double bond OH? This is considered as acetic acid. Acetic acid is containing in vinegar, right? Vinagiri, vinegar, right? So likewise, we can go for a huge list, right? We can consider even phosphoric acid, H3PO4. So likewise, acid means a chemical substance releases H plus in an aqueous medium, right? You have to remember that one. Now you know that these acids are releasing H pluses, right? Just look at this only. Look, let me consider HCl. When we dissolve HCl in water, what will happen? When we dissolve HCl in water, this HCl is dissociating into H plus cation and Cl minus anion. AQ means aqueous, okay? That means it is dissolving in water, right? HCl is an acid. Acid means a chemical substance that can release H pluses in aqueous medium. So you can see that the dissociation is taking place here for HCl, producing H plus and Cl minus. And can you remember, I want to remind you here, acid can be classified again into two different ways. This is actually grade 11, I think, unit number 7, but it's okay, right? Acid. What are the two types of acids? Yes, correct. Weak acids and strong acids. Weak acids and strong acids. Okay? Weak acids and strong acids. What does mean by a weak acid? Weak acid means an acid that is ionizing partially, incompletely, right? So we can say that the acids which ionize incompletely, right? Or else I can say partially, right? If I explain this one further, that means, students, now when you consider acetic acid is a weak acid. That means it's not providing the total H pluses to the medium. It's hiding some amount of H pluses within itself without releasing H pluses to the medium. That's why we tell it is not completely ionizing. Weak acids are incompletely ionizing, partially. They are giving small amount of H pluses to the medium, that's all. Right? They are giving small amount of H pluses to the medium, that's all. They are not giving complete amount. But strong acids are not like that. Right? So strong acid means the acids which ionize completely in an aqueous medium. Completely in an aqueous medium. Okay. Then what is the summary? Try to understand. Acid means a chemical substance that releases H pluses in an aqueous medium. We can give some examples like HCl, HNO3, sulfuric, H2CO3, CH3C double bond OH. And remember the formulas and the names, right? HCl means hydrochloric acid, HNO3 means nitric acid, H2SO4 means sulfuric acid, H2CO3 means carbonic acid, CH3C double bond OH means acetic acid. Okay. And students, don't worry. After the class, I'm uploading to the group the recording and the PDF handwritten note is there. What I'm writing here will be uploaded to the WhatsApp group. Okay. So therefore, you can refer that one anytime. SO3 is not an acid. Okay. SO3 is actually acidic gas. That is an oxide. Understood? So acid means, yeah, it has an acidic nature, but it's not a acid. Okay. Acid means actually it should be able to release H pluses. But when you dissolve sulfur trioxide in water, it is producing sulfuric acid, and then it can release H pluses. Understood? So sulfur trioxide has acidic nature, but sulfur trioxide is not an acid. Okay. When you dissolve that one in water only, it is showing acidic nature, right? Then let me give you a few examples for the weak acids. Students, we can consider acetic acid, CH3C double bond OH. Yeah. I will upload the handwritten note to the WhatsApp group. Okay, no need to worry. Then H3PO4, phosphoric acid, right? This is what? Phosphoric acid. Then carbonic acid, H2CO3. So these are considered as weak acids. And for the strong acids, let me give you examples like HNO3, HCl, and sulfuric. So these three are the famous strong acids. Okay. So then here you can see a brief introduction for the acids. Now in this question, they have talked about formic acid, right? Remember, students, formic acid means actually, so as they given, the ants are releasing formic acid, right? So when the ants bite, so you can see that the red color ant, have you seen that? The red color large one. So actually they're releasing formic acid. That's why we have a small pain there, right? So this is acid. They're releasing acid. Formic acid is actually something like this. right? It's a carboxylic acid, right? Then, yeah, Demio, yes, right? So this is the acid of the compound of formic acid. You don't have to remember that one. I just gave you the structure for your extra knowledge. Huh? This is extra knowledge. Then try to understand in order to neutralize an acid, right? Now, in the question they're asking, look at it carefully. In question number 4, they're asking the cause for the pain when stung by red ants in the formic acid which they apply on the sting. Application of which of the following on the sting is most effective to relieve the pain? Then we have to put the opposite thing, right? Now this is formic acid. Then we have to neutralize it. We have to reduce the acidic strength. Okay, students, tell me, that is general knowledge. In order to reduce the acidic strength, what we have to put? Simple, right? We have to add a base. That is the simple thing, right? We have to add a base. Then let's discuss about bases, right? Acid means a chemical substance release H pluses in aqueous medium. Then tell me, what does mean by a base? How do you define a base? Tell me.
Release OH minus ion.
If acid is releasing H pluses in aqueous medium, a base means? A base means something that can release OH minus, right? OH minus. Understood? So, let me write down the definition for the bases in this way. Base is a chemical compound that increases the hydroxide ion, OH minus, hydroxide. This is known as OH minus, hydroxide ion. Concentration of an aqueous medium. Simply we can say someone who can release OH minus to the medium. Right? So let me give you a few examples for them. NaOH, KOH, NH4OH, sodium hydroxide, right? Sodium hydroxide, potassium hydroxide, Then what about this? Ammonium hydroxide, right? So these are the bases. Can you see that they are releasing OH minus? Now let me consider sodium hydroxide. Sodium hydroxide aqueous. Sodium hydroxide aqueous is releasing Na plus sodium plus aqueous cation and OH minus aqueous anion in this, right? So that is how the base is working, children. That's how a base is working. Sodium hydroxide aqueous releasing sodium plus aqueous cation and OH minus anion. OH minus means hydroxide. Is it clear? Right. So likewise, in the acid classification, now we learned acids are two types, weak acids and strong bases. So here also, yeah, you have to remember them, students. Okay, in the textbook also they have given these things. So therefore, definitely you have to remember the names and formulas. Okay, students, children, you have to remember the names and formulas, right? Then, as before, bases also can be classified into two: weak bases and strong bases. Weak bases and strong bases, right? And what are the examples? Now, same thing. What does mean by a weak base? A base which is partially dissociating, incomplete dissociation, incompletely ionizing. And what does mean by a strong base? a base which can completely ionize in an aqueous medium, right? Same definition as in acids. For the weak bases, we can say ammonium hydroxide, NH4OH. Let me give you another example. Number 2, methylamine, right? What is this? Methylamine. Methylamine. Just remember this example, addition to that ammonium hydroxide. Then strong bases, we can say potassium hydroxide, sodium hydroxide, okay? This way. So they are strong bases. Clear? Now let's move to the question again. So what are the answers they have given? Can you see a base they have given here? Salt water. Salt water is not a base, right? Salt water is not a base. Water. Remember, students, water is actually a neutralized form. And vinegar, right? Just now I told you vinegar means actually acetic acid. CH3, C double bond OH, COOH. This is acetic acid. What is it? Acetic acid. That means vinegar is containing an acid. Therefore, we can't use vinegar to neutralize formic acid. And what is this lime water? What is lime water? Do you know the formula of lime water? Yes. Lime water is a base. Exactly. Yalidu. Right. Can anyone tell me what is the formula of lime water? Then it should be a base, right? That means it should be someone's hydroxide. So who is that someone? Yes, correct. Rosin, yes, correct. Calcium hydroxide. Remember, lime water means nothing else but calcium hydroxide. Calcium is which element? What is the atomic number of calcium? I hope you can remember the first 20 elements in the periodic table. Do you? Right? Let's read one time. What are the first 20 elements? Yes, this is the 20th element. Calcium is the 20th element, right? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Right? So some of the students are used to remember this one as a song. Okay. I don't know about those stuffs, right? I just remember the first 20 elements. So you also should remember that one. Okay. Calcium is the 20th element in the periodic table. So therefore, lime water means calcium hydroxide. So therefore, question number 4, answer is third one. Easy. Now, what are the doubts you have? Anything? You can ask me. Do you have any doubts, children? Lime and lemon water? What is that? Right. Okay. No, there is no connection between lemon and lime here. Okay. So lime water means calcium hydroxide. That's all. Okay. Right. So the next one, which of the following species contain 10 electrons, 11 protons, and 12 neutrons? Okay, this is a basic question type. This is a basic question type regarding the electrons, protons, and neutrons. Okay. Yeah, Ramla, let's see what is the answer. But before that, I want to revise here a few things. Let's see whether you have the basic knowledge, grade 10 knowledge. Recall what we learned. This is MCQ number MCQ number 7. Right. Students, since they're asking about the number of electrons, protons, and neutrons, what are the main three subatomic particles? What are the main three subatomic particles? Yes, quickly. Answer me. The first one is electron. Second one is proton. And third one is neutron. Electron, proton, and neutron. So these are the three subatomic particles, right? So the symbols of electrons. So symbol of electron is E minus 1, 0. Proton is P 1, 1. And neutron is 0, 1. Can you tell me electron was discovered by whom? Electron was discovered by? Quickly. Who discovered the electron? Yes, J.J. Thomson. Then proton was discovered by Ernest Rutherford, right? Proton was discovered by Ernest Rutherford. And neutron was discovered by whom? James Chadwick. James Chadwick. In this way. Right? So you just remember these things. Electrons, protons, neutrons discovered by them. I think they haven't mentioned those names, but I'm just giving you. Electron was discovered by J.J. Thomson, proton Ernest Rutherford, and neutron was James Chadwick. Okay. And when you consider a particular element, right, you should know about the atomic number and the mass number, right? Let me consider the element potassium, right? Students, we know that potassium 1939. So what is the atomic number? Atomic number is 19. And what is the mass number? Mass number is 39. Right? Atomic number is 19 and mass number is 39. Right? And you know that what does mean by the atomic number? Atomic number is representing number of protons. Right? Atomic number is representing number of protons in an element. Clear? Then mass number. What is this mass number? Mass number is representing number of protons plus number of neutrons. Okay, number of neutrons. Now, look at this one, Elio. Manganese, right? Okay, you don't know about this element. It's okay, fine. There is an element known as manganese in the periodic table. Manganese is 25, 55. Okay, tell me how many electrons are there? What is the electron count for manganese? Mn. This is not magnesium, this is manganese, right? Electron count is 25. Then what is the proton count? What is the proton count? 25. Then how many neutrons are there? What is the neutron count? It's 30. It's 30, yes. Then you have to understand that electron count and proton count is also same. Number of electrons equals to number of protons. Right? In this way. Clear? So what is the atomic number here? Atomic number is 25. And what is the mass number? Mass number is 55. Right? So in the left side down corner, we have atomic number. Right? Atomic number. In the left side upper corner, we have mass number. In this way. Right? And this is what you have to know about the simple subatomic particles, atomic number and the mass number. And in addition to this one, if you can remember under the third lesson in grade 10, structure of matter, you have learned about the energy levels, K, L, M, N energy levels, can you remember? And where exactly the protons and neutrons are located? Where exactly the protons and neutrons are located? In an atom? Yeah, in the nucleus, right? In the nucleus, exactly. Now this is the, just imagine this is the nucleus and right? Okay. Right. Now this is the atomic nucleus. When you consider an atom, the atomic nucleus is located inside the center of the atom. So this is the place we can see the protons and neutrons. Atomic nucleus is neutral. And what are these circles, students? Can you remember what are these circles? These are known as, quickly, energy levels. Yeah, exactly. These are known as energy levels. These are known as energy levels, right? Energy levels. Electrons are located in these energy levels, no? Electrons are located in these energy levels, right? This is the structure of an atom, right? A structure of an atom. When you consider the structure of an atom, at the center, we can see the atomic nucleus. Atomic nucleus is neutral, and that is the place where protons and neutrons are located, gathered together. And electrons are located around the atomic nucleus in certain parts. They are known as energy levels. What are they? They are known as energy levels. Electrons are located in energy levels. And these energy levels are named by K, L, M, N. Right? And maximum number of electrons that can occupied in K is 2. L is 8. M 18 and N 32. Okay. Understood. Maximum number of electrons that can occupied in the first level. That means K is 2, L is 8, M is 18, and N is 32. Clear? Right. So that is a brief introduction for the atomic structure. Now let's move to the next MCQ. Which of the following species contains 10 electrons, 11 protons, 12 neutrons? Right? What is the answer for this one? Students, they have given 10 electrons, 11 protons, and 12 neutrons. Look at that carefully. Now, we know that if they have given 10 electrons, the electron count is 10, proton count is 11, and neutron count is 12. So, first of all, we have to identify atomic number. What is the atomic number? What is the atomic number of this element? Just now we discussed. Atomic number means number of protons, 11. Then tell me, who is the 11th element in the periodic table? Sodium. Sodium is the 11th element. Then sodium. Then atomic number 11. And neutron count is 12. So we know that mass number equals to mass number equals to 11 plus 12, 23. Then this is the mass number. But they have mentioned electrons are 10. Usually, children, electron count and the proton count both are same. Okay. Usually, electron count and proton count both are same. But here, electron count is 10. What does mean by that? That means the sodium atom has removed one electron and it has produced sodium plus cation. This is known as a cation. Sodium plus cation. Plus one charge. Okay. Plus one. And remember, some of the students are writing. Now just imagine magnesium is releasing 2 electrons and producing magnesium 2 plus. Students, don't write magnesium plus 2. Okay, that's wrong. That's wrong. Do you know why they have mentioned 2 plus like this? Because it has released 2 electrons. Then magnesium has these kind of 2 positive charges. So that's why we write Mg2 plus. Is it clear? Now, when you consider aluminium 3 plus, don't write that one as aluminium plus 3. That's wrong. It's wrong. Right? Actual meaning of this one is, right? Actually meaning of this one is aluminium is having 3 plus charges, extra charges. So we condense it and we write it aluminium 3 plus. Is it clear? Right? Then this is about sodium plus because it has released 1 electron. Then what is the answer for this one? So we can say, which of the following species contains 10 electrons, 11 protons, and 12 neutrons? Answer is second one. Yeah. All right. Raise your hand those who understood that. Do you have any doubts there? If you have any doubts, put your doubts in the chat box. Right. All right. Okay. And now the next question. This question is related to unit number 3 in grade 11, mixtures. Okay. So look at this one. The essential oil methyl jasmonate is the cause for the fragrance of jasmine flowers. Right? Picture mark, jasmine flowers. Which following method could be used to separate methyl jasmonate industrially from jasmine flowers? Right. Any answer? Put your answers in the chat box. Yalindu, your answer is correct. Maria, your answer is correct. Shadia, your answer is correct. Very good. Yes, others also put the answers. Razin, yes, that's the correct answer. Yeah, second one is the correct answer, right? Steam distillation. So you have learned about this steam distillation, right? Fractional distillation, chromatography, right? Vaporization, simple distillation. So these things under the uh, unit number 3, under the mixtures, right? So let me discuss about this process a little bit. It's a small process. First of all, what does mean by an essential oil? Essential oil. Remember, students, essential oils are vaporizable oils which are taken from plants and animals, right? Let me write down here. Now, this is MCQ number 8, right? Yeah. Essential oils. Now, essential oils means we know that the vaporizable oils which are taken from plants and animals. Okay. What are the examples? What are the examples? We can consider lemon, sandalwood, lemongrass, eucalyptus, clove, nutmeg, citronella, and cinnamon. So these are the essential oils examples. Actually, cinnamon is taken from the cinnamon tree bark. Bark of the cinnamon tree can be used to take the cinnamon oil. Right? Cinnamon oil means kurudu tel. All right. Then what are the methods of extracting essential oils? Can you remember? We learned the methods of extracting. Actually, here they are asking the methods of extracting. One of the methods extracting essential oils. Yes, these examples are important. In case if they ask you this one in the essay paper, you should be able to answer. Therefore, please remember at least 3 examples. Here, in order to extract these oils, essential oils, The methods that we are using is one is squeezing. The other one is solvent extraction. Solvent extraction. And then we have steam distillation. Steam distillation. Right. Now study these three. The methods of extracting essential oils, one is squeezing, solvent extraction, and steam distillation, right? So let's discuss about these three in detail under the theory revision. Now just try to understand the methods, right? Now, when we discuss about I'll discuss about this steam distillation in brief, right? Look at this. Properties of essential oils. Suitable to be extracted by steam distillation. The first one should be vaporizable. Otherwise, we can't use this steam distillation method. They should be vaporizable and does not mix with water. Does not mix with water. Otherwise, we can't use this method. And density of water and oil differs. Density of water and oil differs. Otherwise, what will happen? They are going to mix. We can't separate the oil. No. Remember, in order to use this steam distillation method to extract essential oils, these are the three properties that should essential oils suitable to be extracted. One is vaporizable, doesn't mix with water, and the density of water and oil differs. Water and oil differs. Okay, so these three are the properties. Now, when you go for the method, let me write down bullet point wise. Right now, what will happen is in the steam distillation, water vapor and cinnamon oil. Let's take cinnamon oil. Let's consider cinnamon bark. Water and cinnamon oil vapor pass out from the broiler after steaming cinnamon leaves. We are taking cinnamon leaves, right? The method in brief, method in brief, water vapor and cinnamon oil vapor pass out from the broiler after steaming cinnamon leaves, or else we can take citronella also. Then the tube containing oil and oil vapor and water vapor oil vapor and water vapor is immersed in water to cool the mixtures. To cool the mixtures. Then water is denser. Then water is less denser than cinnamon oil. So water floats on cinnamon oil. Then easily we can remove water and extract cinnamon oil. This is the process, right? Water vapor and cinnamon oil vapor pass out from the broiler after steaming the cinnamon leaves. So very easy. We are taking the broiler and we are steaming water and cinnamon leaves together. Then water vapor and cinnamon oil vapor both are actually vaporizing. So that both vapor, that means oil vapor and the water vapor, both are immersed in water and cool the mixture. Then what will happen? Water has less density than cinnamon oil. So therefore, water is floating on cinnamon oil and we can extract cinnamon oil. That is the process in brief. Okay. Then here, as we discuss, the answer should be second one, right? Have they given the diagram in your textbook, students? I think they have given the diagram. No? So this is the steam distillation method. Okay. Can you remember the setup that they have given in your textbook? Right. Okay. So this is the setup, right? They are using cinnamon leaves. See, cinnamon leaves here and water. So the vapor is actually going like this through this tube. So this is actually Liebig condenser. If you go to your science lab, you can see that one, right? And you can see finally water and oil both are mixing. So since water has less density here, water is floating here, right? This is water. And this is the cinnamon oil. So we can remove water and we can get the oil, right? So this is the setup to take water vapor. And in this setup, you can see that water vapor is added here and then cinnamon leaf is also here. In this setup, we can separate the water and cinnamon oil, right? Right. Okay. No, it's not. It's not broiler. It's boiler. Any doubts, children? What are the doubts you have? Yes. Remember the examples again. No. No, no. Some of the oils are actually, now when you consider, typically oil is actually less denser than water. Oil is floating on water. But when you consider cinnamon oil and water, Amir, cinnamon oil is actually having a high density than water. Remember that, okay? Maybe that is a MCQ point. You might confuse there, right? Cinnamon oil has higher density than water, right? Cinnamon oil's density is around 1.01 to 1.06. Density of water is 1 grams per cubic centimeter. So therefore, water is floating on cinnamon oil. Understood? Right? Right. Now let's move to the next question. As I told you, I'm going to revise the theories related to these questions. So therefore, nothing to worry, okay? Even though you don't have any previous knowledge, you can go through these questions. Let's gather the knowledge, right? So the next chemistry question that we have is, what are the next one? MCQ number 15. So what they have given here, X, Y, and Z are three successive elements in the periodic table, and X is a noble gas. As which of the following species is not is Z most likely to exist in its compounds? Right. They have given X, Y, Z are three successive elements in the periodic table, and X is a noble gas. As which of the following species is Z most likely to exist in its compound? Right. Now here they have asked about the periodic table, right? So let's go for the periodic table. Okay, this is actually a good chance to revise the periodic table for all of you. MCQ number 15. Periodic table. The modern periodic table is containing 118 elements. Children, there are 118 elements in the modern periodic table, but we are not going to discuss that one in O levels. We just discussed 20 uh, elements in the periodic table. Right. So, can you remember it? Starting from hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Right? Then we know that in the periodic table, how many rows are there in the periodic table that you are learning? 4. And they are known as, these rows are known as Periods, exactly. And how many columns are there? 8 columns. And they are known as groups, right? They are known as groups. Right. So there are 4 periods in the periodic table. 1, 2, 3, 4 in the periodic table that you learn. Okay. Right. This is not the exact periodic table. I'm telling you again. And how many groups are there? So there are 8 groups, the columns. Right. So we consider vertical columns. They are known as groups. Then horizontal rows, they are known as periods. Right. And group number is representing number of electrons in last energy level. And period number is representing no 1 to 8 is groups. Okay. So 1 to 8, they are groups. Period number is representing number of energy levels. Energy levels in an atom. Okay. Right. Then there are a few classification you have to know. Look at this one. What are the noble gases in the periodic table that you learn here? Noble gases. Helium, neon, argon, right? They are noble gases. Noble gases. Helium, neon, and argon. Right? Then what are the metals in the periodic table? Lithium, sodium, potassium, beryllium, magnesium, calcium, aluminium. So these are metals. Lithium, sodium, potassium, beryllium, magnesium, calcium, aluminium. These are metals. Right? Then boron and silicon. Can you remember the specialty of boron and silicon? Yes. So what are boron and silicon? Metalloids. Yes. And what does mean by metalloids? Metalloids means they are having both metal and non-metallic properties. They can act as a metal as well as a non-metal. Boron and silicon. Right? Then what are the non-metals? Carbon, nitrogen, phosphorus, oxygen, sulfur, right? So they are considered as what? Non-metals. All the remainings are non-metals, right? Even helium, neon, argon, fluorine, chlorine. So all of them are non-metals. non-metals, right? Carbon, nitrogen, oxygen, fluorine, neon, helium, hydrogen, phosphorus, sulfur, chlorine, argon. Remaining everything are considered as non-metal. Even hydrogen is a non-metal, right? And halogens, who are the halogens? Have you heard about halogens? Who are they? Fluorine and chlorine, they are halogens, okay? Fluorine and chlorine, they are considered as halogens. Halogens, fluorine and chlorine, okay? Right. So that is not important, but mainly you have to know about what are the noble gases, metals, metalloids, and nonmetals, right? Okay. Now, let's move to the question again. They have given X, Y, Z are three successive elements in the periodic table, and X is a noble gas. As which of the following species is Z most likely to exist in its compounds, right? Then what could be the answer? Yes, tell me, students. Now, if it is a noble gas, X is a noble gas, then we can say, let's take neon. Neon is X. Then sodium is Y and magnesium is Z. Then magnesium is producing what? Magnesium plus or magnesium 2 plus. What is it? Oh, it is an ion. Magnesium is producing magnesium 2 plus. Clear? Magnesium is producing magnesium 2 plus. So therefore, what is the answer here? So answer here is the second one. Is it 2 plus? Very easy. That's very easy. Right? Raise your hand those who understood that. Do you have any doubts there? If you have any doubts, put your doubts in the chat box. Right. Good. We can take helium or argon, doesn't matter. Right? Even if I take helium, what will happen? Helium, lithium, beryllium. Beryllium is also producing 2 plus. If I take argon, potassium, calcium. So beryllium, magnesium, calcium. So the second group elements are always producing plus 2. Okay. So Z is actually second group, beryllium, magnesium, calcium. Now beryllium-like elements. Beryllium is producing beryllium 2 plus, magnesium is producing magnesium 2 plus, and calcium is producing calcium 2 plus. So therefore, the element Z should be second group. Okay. Right. Okay. Students, now time is 10:40. Let's have a break. Okay. So I'll start the class at, let's take a 15 minutes break. Let's start the class at 10:55. Okay, let's have a small break. Right, okay. Let's start. So what is the next question? MCQ number 20, all right? The hydrocarbon with molecular formula C5H12. They're asking what is the hydrocarbon with the molecular formula C5H12, right? So what is it? Now, remember students, let me give you a small introduction for this one also. In organic chemistry, we have some branches to discuss, like inorganic chemistry, physical chemistry, right? Environmental chemistry, general chemistry, all right? So likewise, there are some branches. And do you know about organic chemistry? Organic chemistry means we are going to discuss about the carbon containing compounds. The compounds containing carbon are commonly referred to as organic compounds, right? So organic chemistry means carbon containing compounds. Simply. Under these carbon containing compounds, we are learning something known as hydrocarbons. This is the last chemistry topic in the grade 11. Okay. Hydrocarbons and their derivatives. Unit number 14. Right. I think most of you haven't learned it yet, but it's very easy. Okay. So hydrocarbons means organic compounds which are containing hydrogen and carbon. Right. So hydrocarbons means the organic compounds containing hydrogen and carbon only. Hydrogen and carbon only. Right. So, for example, we can say petrol, diesel, kerosene, LP gas, methane. So, these are the example for the hydrocarbons, right? Carbon and hydrogen containing compounds, right? We can say petrol. Do you know the formula for petrol? C8H18. Just for your knowledge. This is what we consider as octane. There are 8 carbon atoms and 18 hydrogen atoms, octane. Then we can consider diesel, kerosene, LP gas, liquid petroleum gas, right? The gas cylinder is containing a propane and butane mixture. Propane and butane mixture, right? LP gas is containing propane and butane mixture. Then methane, right? And wax. So these are what? Hydrocarbons. Is it clear? So hydrocarbons means then carbon and hydrogen containing compounds, right? Under the structure of the hydrocarbons, we are classifying them as alkenes, and alkynes, right? hydrocarbons classified as alkanes, alkenes, and alkynes. Okay, what are they? Again, alkane, alkene, and then alkyne. Right? Alkane, alkene, and alkyne. Normally, alkanes means carbon-carbon single bonds. Alkanes means carbon-carbon double bond. Alkynes means carbon-carbon triple. Right? You just know about these things. Then the simplest alkane compound. Now we are going to discuss about alkane. In your textbook, they have discussed about alkanes, right? So you have to understand in alkanes, they are only single bonds. Single bonds present in the alkanes. Between carbon-carbon atoms. So the simplest hydrocarbon, children, remember simplest hydrocarbon is CH4. What is CH4? Simplest hydrocarbon is CH4. What is it? Methane. Yes, methane. 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 Right. What is the structure? One carbon atom surrounded by four hydrogen atoms. CH4. Right. Now alkanes are having a series. Okay. Alkanes are having a series. Now alkanes, only one carbon atom here. This is methane now. Then there is another structure, ethane. There are two carbon atoms. So here formula is CH4 and here formula is C2H6. Can you guess the next one? What is the next one? What is the next one? Can you guess it? Yes, you can. Yes. Kavin, you are correct. Amir, you are correct. Razin, you are correct. Right? It is C3H8. Exactly. 3 carbon atoms and 8 hydrogen atoms. Right? This is considered as methane. This is ethane. If there are 2 carbon atoms, eth. 1 carbon atom, meth. If there are 3 carbon atoms, it's propane. Right? What about if there are 4 carbon atoms? In your textbook, they have given up to 5 carbon atoms. What is this? Butane. Yes, butane. Right? So this is what you can see in LP gas, propane and butane mixture. Butane means C4H10. Here comes the next one, pentane. C5H12, pentane. Right? Methane, ethane, propane, butane, pentane. After that, we have hexane, heptane, octane, nonane, decane. So you don't need to remember those things. You can just remember these steps. Right? Look at the hydrocarbons, simplest hydrocarbon, alkane. So these are alkanes, alkane series. Alkanes means always carbon-carbon, single bonds are connected. Right? There are alkenes also, carbon-carbon, double bonds are there. I'll discuss that one under the theory revision. The last topic, hydrocarbons. We have to discuss about polymers also, PVC, Teflon, and everything. And rubber, small introduction for rubber. Rubber is also polymer. So I'll discuss those things under our theory revision. Now you have an idea about the alkane series. Now, let me write down together in this way: methane, C2H6 ethane, C3H8 propane, C4H10 butane, C5H12 pentane. Children, can you suggest me a common formula for this? Right? Now you have learned arithmetic progression, geometric progression in your grade 10, grade 11 maths. Right? So using that knowledge, can you suggest me a common term? Nth term, you know that nth term in arithmetic progression. Can you suggest me that one? Use your maths knowledge. Suggest me a common formula for the nth term in the alkane series. What is the nth alkane? Yes, correct. Razin, you are correct. Very good. What about the others? Anyone else? Yes, you can try. What is the common formula? What is the nth term? Yes, Abhiram, you are correct. CnH2n plus 2. This is the common formula. Let's substitute n equal 1, n equal 1. Then what is it? C1H 2 into 2, 2. 2 into 1 is 2 plus 2, 4. CH4. N equal 2. C2, 2 into 2 plus 2. C2H6. N equal 3. C3 H2 into 3 plus 2. C3H8. N equal 4. C4, 2 into 4 plus 2. C4H10. C5H12 in this way. CH4, C2H6, C3H8, C4H10, C5H12. See? This is the alkane series. And the common formula is C5, CnH2n plus 2. Right? Is it clear? Alkane series. Now, in this question, Yeah, for the alkene, H2N, alkyne 2N minus 2. Very good. Umair, yes. Those are the common series for the alkenes and alkanes. Very good. The hydrocarbon with molecular formula C5H12. Right. What is the name of this compound, students? So, who is this C5H12? Pentane. Pentane. Okay. Just now we discussed pentane. Is an alkene? No. No, no. It's an alkane. It's a component of a biogas. What do you think? Is it a component of a biogas? No. Normally, methane is the component of a biogas. Right? Next one. C5H12 can be polymerized. Right? It's not polymerized, students. Right? Now, we know that alkenes like molecules can undergo polymerization. Because to undergo polymerization, there should be double bonds. Right? For an example, yes. What does mean by a polymer? Right? And what does mean by the polymerization? Remember, students, formation of a large molecule. Formation of a large molecule by the joining of many small molecules is known as polymers. And formation of these polymers is known as polymerization. Let me give you a simple example. Polythene, right? Polythene is a polymer. How this polythene is made? Right? Remember, students, there is a hydrocarbon known as ethene. This is alkene. See, carbon-carbon, double bond is there, no? This is alkene. The name of the compound is ethene. Ethene. Right? So what will happen is this carbon-carbon double bond is broken. And here, two unoccupied bonds are there. This is considered as repeating unit. What is it? This is known as repeating unit. And now, these kind of C2H4 groups are connecting again and again and again and again. Millions of compounds are connected. Thousands of compounds are connected. Right? Let me consider n times. Okay? Then this is the polymer. Can you understand? Right? This is considered as monomer. 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 Right? What will happen? The double bond is broken. Right? And then this is the repeating unit. This repeating unit is connecting to each other n times. N times maybe 1,000 times, million times. Then it's a large macromolecule. Large molecule, it's a macromolecule. So polymer means formation of large molecule by Joining of small, many molecules is known as polymerization. Can you understand? So this is actually known as polyethene or else polythene. Polyethene or else polythene. Is it clear? Now, can you understand what this mean by the polymerization? Let's discuss other examples in the theory revision. We are discussing about PVC, polyvinyl chloride, right? Polytetrafluorine, Teflon. Okay, so let's discuss our natural polymers are there. You know that rubber, protein, DNA, starch, cellulose, RNA. So these are what? Natural polymers. Okay. Under the theory revision, I'll discuss these polymers in detail. Okay, that is very interesting lesson. This is grade 11, last chemistry unit. Sometimes you haven't learned this one yet in the schools or in your theory class. But soon you will learn it. Okay. Now you have an idea about the polymers also. Raise your hand, those who understood the idea of polymers. Do you have any other doubts? If you have any doubts, put your doubts in the chat box. Right, good. Then let's move to the question. Then these kind of C5H12, these are alkanes. Alkanes do not undergo polymerization. So can be polymerized. That's wrong. That's wrong. Form 6 moles of water on complete combustion of 1 mole. Students, do you know how to write down the combustion reactions? Especially hydrocarbons. What does mean by the combustion? Combustion means reaction with oxygen. Now C5H10 reacting with oxygen. Remember, always, right? Now this is a common thing, common rule. Always. Hydrocarbons, any hydrocarbon, whether it is alkane or alkene or alkyne, doesn't matter, any hydrocarbon, when it is undergoing combustion reaction producing carbon dioxide and water, CO2 and H2O. Children, when a hydrocarbon is undergoing combustion reaction means reaction with oxygen producing carbon dioxide and water. Now let's try to balance the reaction, and you tell me by looking at the left side how many carbon dioxide molecules should be there in the reaction. Balance the reaction. Easy. Yes. So there are 5 carbons, no? In the left side, there are 5 carbons. Then let me put here 5. How many hydrogens are there? 12. Then students, already 2 hydrogen is there. Then let me put 6. Because 6 into 2 is becoming 12. Right? Then totally how many oxygens are there in the right side? 5 into 2. And here 6 into 1. Then 10, 16. 16 oxygens are there in the right side. Then here 8. 8 oxygen. right? Shall I balance it again? There are 5 carbon atoms in pentane, 5 carbons. So therefore 5 carbon dioxide. Then 12 hydrogen, that means 6 H2O. Because students already 2 is there, then 6 into 2 is 12. Now count the total oxygen in the right side. 5 into 2 is 10, and here 6, 16. Then 8 total. Then this is the balanced reaction. So what they have given in the question, forms 6 moles of water on complete combustion of 1 mole. Yes, correct. That is the answer. Fourth one is the answer. Right? That is the answer. Question number 20. MCQ number 20. Answer is fourth one. Okay, now let's move to the next one. Next MCQ, MCQ number 23. U, V, and W are 3 metals lying above in the activity series. Above hydrogen in the activity series. The method proposed by a group of students to compare their activity was taking a piece from each metal, reacting with them hydrochloric acid separately, and comparing the volumes of hydrogen gas liberated within a fixed short period. Which of the following factors is not essential to keep constant during the experiment? Okay. Now, this is regarding the rate of reaction. If you can remember, this is regarding rate of reaction. Right? So, students, the first thing is, what does mean by the rate of a reaction? What does mean by the rate of a reaction? Now, how do you measure the rate of a reaction? Time taken for reaction. Yes. Simply, we can say that rate of a reaction means speed of a reaction. Rate of reactions. Simply, we can say speed of chemical reactions is measured as rate of reaction. Right? We are using the symbol R. For the rate of chemical reaction, we are using the symbol R. There are 2 methods to measure the rate of a chemical reaction. there are two methods to measure the rate of chemical reaction. Okay. First one, what is the first method? We can measure the rate of the reaction by the time taken. By the time taken to liberate equal volumes of gases. Number two, second method is volume of the gas liberated at a definite time interval. Time interval. Right? Now, can you tell me which method we have used in this question? Right? Look at this one. The first method is by the time taken to liberate equal volume of gas. Second method is volume of the gas liberated at a definite time interval. At a definite time interval, the volume of the gas liberated. And the first method is the time taken to liberate equal volume of gas. Let's go for the question again. Tell me whether it is first method or second method. The method proposed by a group of students to compare their activity was taking a piece from each metal, reacting them with HCl acid separately and comparing the volumes of hydrogen gas liberated within a fixed short period. What is the method? First method or second method? Yeah, it's the second method, right? They have measured the volume of hydrogen gas liberated when the metals are reacting with HCl within a short time interval, right? Within a short time period. Then they have used the second method, right? Then they are asking which of the following factors is not essential to be kept constant during this experiment. Indirectly, they are asking, okay, students, indirectly they are asking, what is the factor which is not affecting to the rate of a reaction? Okay, which of the following factors is not essential to keep constant during the experiment? Right? What are the factors affecting to the rate of a chemical reaction? You have to know them. Factors affecting the rate of reaction. Number one, physical nature. Number two, catalyst. Number three, pressure. Number four, concentration. Number five, temperature. These are the 5 factors affecting to the rate of chemical reaction. So other factors are not important, right? The factors affecting to the rate of a reaction is physical nature, catalyst, pressure, concentration, and the temperature. Then, according to this question, surface area of the metal, that is the surface area, that means physical nature, mass of the metals, temperature of the reaction mixture, acid concentration of the reaction mixture, concentration, temperature, surface area, or else physical nature. These 3 factors are affecting, but the mass of the metal is not important. Second one is the answer. Raise your hand, those who understood that. See how easy these questions are. If you know the theory well, if you know the theory very well, answering the questions is not that much of a big deal, students. Right? Children, you learn the theories properly, then apply them for the questions. Right? Let's move to the next one. The next one is 27. What is this? Two metals Q and R react as indicated by the following equations. Q metal is reacting with sulfuric and producing QSO4 hydrogen gas. R is reacting with sulfuric to produce RSO4 hydrogen. Then R is reacting with QSO4, no reaction. Which of the following can be Q and R respectively? Oh, that's a good question. That's a very good question. Now, both of them are reacting with sulfuric, okay? Both of them are reacting with sulfuric, right? And you have learned that in a displacement reaction, highly reactive metal displaces a low reactive metal from its aqueous solution. You have heard that, right? Now, highly reactive metals means in the reactivity series, the upper elements like potassium, magnesium, sodium, right? So those elements actually at the top, right? So can you remember the reactivity series, activity series, right? Shall we recall it? Children, can you remember the activity series? Right. So we know that we have discussed activity series in grade 10. Yeah. Once the class is over, I'm providing the recording, okay? So we know that the arrangement of metals in the descending order of their reactivity is referred to as the activity series, right? Potassium, sodium, calcium, magnesium, aluminum. Remember, these are metals with high reactivity. Remember, these are metals with high reactivity. Then zinc, iron, tin, lead, copper. Metals with mid reactivity. mercury, gold, platinum, aurum. Metals with low reactivity. Okay. So this is the increasing order of the reactivity, or else this in descending order. So for, we can say, bottom to top, increasing order of the reactivity. Right? Recall what you learned in grade 10. Changes in matter. Can you remember the lesson changes in matter? We learned this one. Grade 10. Activity series. Potassium, sodium, calcium, magnesium, aluminium. These are the metals with high reactivity. Zinc, iron, tin, lead, copper. These are the metals with mid reactivity. Mercury, silver, platinum, aurum. That means gold. These are the metals with low reactivity. Right? Now, for an example, right? Look at this one, Illu. Reactivity with acids, reactivity with water, okay? Reactivity with the other metals, right? Oxygen, reactivity with oxygen. Right. Now, can the metal, yes, what is the doubt? Can the metals in the same reactivity level react with each other? No, they can't react with each other. Now, for an example, sodium and magnesium, sodium and potassium, they can't react because their reactivity level is in the same level. That means they are highly reactive, and sodium and potassium, they are in the group number 1. They have same chemical properties, right? So they are not reacting with each other. Okay. I'm talking about here reactivity with water, diluted acids, and oxygen. But you should know that relative reactivity, that means compared to the other element, this element's reactivity with water, oxygen, and diluted acid is greater. Now, when you consider potassium and gold, you have to understand that potassium has high reactivity with water, diluted acids, with oxygen than gold. Now, gold is not reacting with water, right? It's not reacting with water. So, this activity series is try to understand, right? In order to understand the relative reactivities between the others. Now, the important theory part for this question is you have to understand here in a displacement reaction. Now, they have given some displacement reaction in the question. In a displacement reaction, yeah. Okay. If you want to copy down these things, quickly copy down. No? We don't have much time. And remember, students, it's not about the quantity, okay? So don't judge how much we have done so far today. So now we have done, I think, only few MCQs. But don't judge in that way. Look what we learned today, actually. Right? I want to revise everything from the beginning because this is paper revision. While discussing the questions in the papers, we are going to revise the theories as well. I hope you revise so many theories today. What we learn in grade 10 and grade 11. Okay. That is the most important thing. You can do questions anytime by your own, right? So we have remaining time for that. But here it's not the thing. I want to revise everything again and again. I hope you can understand. Right. Then in a displacement reaction, a highly reactive metal displaces a low reactive metal from its aqueous solution. Now let's take an example, magnesium and copper. Imagine magnesium is reacting with copper sulfate. Will there be any reaction? When copper is reacting with magnesium sulfate, will there be any reaction? What do you think? Now, in the activity series, which element is more reactive? Magnesium or copper? Magnesium is here, copper is here. Then magnesium is more reactive than copper, right? Then magnesium can displace copper. So what will happen? Magnesium sulfate producing and copper metal is released. In a displacement reaction, a highly reactive metal is always displacing a low reactive metal from its aqueous solution. But look at this. When copper is reacting with magnesium sulfate, will there be any reaction? Can copper displace magnesium? No, no chance. By depending on this theory part, now let's move to the question. Look at the question they have given, right? Now here they have given with sulfuric. Both of them are reacting with sulfuric. Students, both of them are reacting with sulfuric means definitely they have what? High reactivity. Okay, Q and R both are reacting with sulfuric and producing and hydrogen gas is liberated. But when R is reacting with QSO4, there is no reaction. Now tell me, which one is more reactive? Q or R? Q is more reactive, right? Because when R is reacting with QSO4, right? So R cannot displace this Q. That means Q is highly reactive than R. Then choose the correct couple. Which of the following can be Q and R respectively? Copper and zinc. In the activity series, okay, let's move to the activity series. Copper and zinc. Where is copper? Here. Then zinc? Here. Then no, it's not correct. Copper cannot be Q. We can't take it. What is the next couple? The next one is zinc and magnesium. Students, zinc is at the top. Sorry, magnesium is at the top, but zinc is not there. So zinc cannot be Q. Magnesium and copper. Is it possible? Yeah, magnesium is at up. Then copper. Copper is also what? Copper is at the down. Then magnesium and copper can be a suitable couple. But look at the fourth one. Magnesium and zinc. What do you think? Magnesium and zinc. That is also correct. So Q can be magnesium and zinc can be R. Then third one and fourth one both are correct. Then third one and both, third and fourth both are correct. Is it? What do you think? Explain me. Which one should be the correct answer? Right. Children, where is hydrogen in this activity series? Where is hydrogen in the activity series? Remember, hydrogen is actually in between lead and copper. So elements below hydrogen is not reacting with diluted acids. Okay. Remember students, elements below hydrogen is not reacting with diluted acids. But elements above hydrogen is reacting with diluted acids. Now tell me what is the answer. Copper or zinc? It is copper magnesium or zinc magnesium? Then answer is fourth one. Is it clear? Right? In the activity series now, here we are discussing about the metals. No, that's why I didn't include hydrogen here. But hydrogen is actually in between copper and lead. Below copper, below lead, above hydrogen. Above copper. Below lead, above copper. In between lead and copper. All right. Then here they have clearly mentioned that Q and R both are reacting with sulfuric. Elements below hydrogen are not reacting with diluted acids. So therefore we can't take copper. Then definitely this couple should be magnesium and zinc. Magnesium and zinc. Answer is fourth one. Raise your hand those who understood that. If you have any doubts, put your doubts in the chat box. We can discuss them. See, you have to remember the activity series. Very, very important. Right? In order to answer for these kind of questions, you have to remember activity series. So important. Yes. So the elements on the top are stronger, so they displace the bottom elements. Exactly. Elements on the top are stronger, so they displace the bottom elements. That's what happened. Right. Yalindu, this is the first day of the class. Yes. Yes, I live in Colombo. Yalindu, that is depends on your your target. Now, some of the students are actually shifting to uh, local A levels after doing Edexcel O levels. Because I have seen so many students like that. Still, I'm teaching for those kind of students. But I haven't seen maybe some of the students are there actually after doing Edexcel, after doing locals, and they are doing Edexcel A levels also. Advantage is actually you can finish your A level examination earlier than in local A levels, and you can enter to the universities. You can get the scholarships in the other countries. But doing local A levels is actually having a high standard. Understood? Now entering to Colombo medicine, right? Paramedicine. So that is a high standard. So that's why most of the students are those who are interested in becoming doctors, engineers. They are choosing local areas. Okay, so that depends on your target. If you want to become a doctor anyhow, you can go in that path also in Excel A levels and everything. In order to become a doctor engineer, you can go to that path. If you think that if you want high standard, high ranking doctor or engineer, definitely you have to do local A levels. Okay. The best medicine university is Colombo University. For engineering, the best is Moroto University. Yes, I'm discussing chemistry lessons again, as I told you, as I promised. Definitely, I'm going to discuss them. Right? Don't worry about it. Yes, good. Don't worry, we will be continuing this one till the exam. So you can ask any doubts regarding chemistry related things. Send me a message, drop me a message. We can discuss. Okay. For business management, I think it is Japura. Yeah, Japura, I think. I did A-level maths, so therefore I don't have any idea about it, but I think it's Japura, no? Right. Okay, students, then these are the things that we have to discuss today. I will upload the PDF and the recording to WhatsApp group. Next week, then we will be discussing the remaining questions in this paper. Yeah, probably next week we can start essay questions also. So how about Peradeniya campus for science? Yeah, Peradeniya University is for now. Normally, science faculty is good, engineering faculty is good, medicine is also good. Normally, maths bio students, that means physical science and bioscience students are going for Peradeniya University. Peradeniya University is good. So, do you think about London A levels, biochemistry and physics? Do you think about London A level? That means, what do you mean by that? That means you're asking whether I'm teaching London A levels. No, I'm not teaching London A levels. And if you're choosing London A levels, that's fine, right? As I told you, you can't enter to the government universities, state universities. You have to go for foreign universities, which are not that much rank universities for medicine engineering. Others are okay, I guess. I think, right? My advice is actually better you do local A levels, whatever the subject stream is, because actually, if you can enter to a government university, that will be a value addition for your future. Okay. Peradeniya medicine medical faculty is really good. Science faculty is also really good. Okay. I went to Colombo University. I did physical science. I completed my Bachelor of Science degree in Colombo University. So Colombo is best for medicine. Moratuwa is best for engineering. For bioscience and physical science also, Colombo is the best. Now raise your hand, those who are planning to do A-level maths or bio. Let me see. Okay, only few. Raise your hand, those who are planning to do A-level commerce. Anyone who is planning to do tech subjects? Okay, good. Children have a target, so work for that target from now. Okay, that means your future is completely depending on your path that you're choosing in A levels. Okay, not in O levels. I want to do something from the ICT side like CS. Then better you do. You can go in commerce stream also. Even you can go in math stream also. Because some of the students are there Now in A-level students, we have a subject combination, combined maths, physics, chemistry. Some of the students are there, they are dropping chemistry and they're choosing ICT instead of chemistry. So they can't enter to the engineering, even though they did combined maths, A-level maths, they can't go to the engineering since they drop chemistry. In order to do chemistry, in order to do engineering or medicine, definitely you have to do chemistry. But some of the students are there, they're not their plan is not doing engineering. They want to go for computer science, software engineering, those kind of things. Then you can drop chemistry and you can choose ICT. Yes, you can do ICT. That means some subject combination is like that. Combined maths, ICT, physics. All right. So you can enter to the Colombo CS, Ruhuna CS, Kelaniya C is there, software engineering, Kelaniya software engineering is there. Right. Morotu IT is there. So there are so many options. Understood? Right, okay. Raise your hand those who understood the things that we discussed today. All okay? Raise your hand those who understood the things that we discussed today. Right. Okay. Then students, I'm going to wind up the session for today. Let's meet on the next Saturday class. We will be discussing the remaining questions in the next Saturday. I will upload the PDF, handwritten note, and recording to WhatsApp group. And if you have any doubts, please send me a message. Okay. Right. Then let's meet on the next week class. Until then, bye bye. Have fun.